All right. Did I record this class or did you just record it the other class? You can tell it was a lot louder. There's a lot more background. Although Cesar, I don't think Cesar was there, so it wasn't loud. Joe, yeah. It wasn't as loud as it is some days. All right. So let's see. Sine 2x. So antiderivative sine is what? Negative cosine. And you're going to kick out another 1/2. So there's going to be a 1/4 cosine 2x plus c, and then 1/2. Oh wait, no, time out. Don't do the c, right? So anyway, so we had definite integral here, right? So definite integral, you treat just like an indefinite integral up until when you get the plus c. And at the very end, instead of just wanting the function, the antiderivative, now we want the value. So we want big F of b minus big F of a, right? Well, what we just found was big F. So we just got done finding big F, the antiderivative, and now we plug in our pi and plug in our 0. So hopefully this works out pretty nice. Sine of 2 pi is 0. That wipes out all that. Cosine of 2 pi is 1. So the whole thing is just 1/4. Now I could write it all out, but I'm going to save myself a little work. Now, if this was a gateway test, I think I'd be a little, if I was writing that out, I would probably be a little, I would be writing stuff out more. But anyway, sine of 0 is just 0. Cosine of 0 is also 1 again. So 1 times 1/4 is 1/4. Oh, isn't that nice? So the whole thing is just 0. Interesting. Okay, so obviously if we were to graph this, there must be some positive area and then some negative area that must be canceling each other out, but we go from 0 to 5. Okay. All right, there you go. That's just a pretty straightforward integration by parts. That's the kind you could expect to do on Wednesday, but you do have that 1/2 you had to kick out, so you did have to kind of keep track of that kind of thing. Emily, what was your question? Just in general.
Yeah, just
just because this is, but did you?
I think the 2x. I don't know why that.
Yeah, it's just this. It's just an algebra, and it's a trig, and so, and of course, first recognize it's integration with parts, right? But yeah, the 2x is part of the cosine. Remember, that's not cosine times 2x, right? It's cosine of 2x. That's all one thing. It's all one thing. Okay, what else? 31. 31.
The integral of x cubed e raised to x squared. The directions where we use the substitution u equals x squared and integration by parts.
Okay, so one of the things we talked about on Friday is sometimes you have to do these twice, because remember what these techniques do is they just turn our integral into a new integral that we can do, right? That's what u substitution does. That's what integration by parts does. It essentially turns it from one integral into another integral that hopefully we can do. Well, it might turn, integration by parts might turn the integral into one we have to do u substitution on. U substitution, so that's what 31 is about. They're telling you, they're giving you a hint. U substitution is going to turn this into an integral that we can do integration by parts on. So that's what 31 is about. Now, what do you think of doing this? Well, you got an inside. So anytime you have an inside like that, you got a function on the inside, you're probably going to have to do a u substitution, right? I mean, even though it's multiplied, so it has the look of an integration by parts. Now, if we were in Calc 2 class, we would be spending more time on these, right? We would be digging into them deeper. That's what you do in Calc 2. Like I said, there's some other techniques we haven't gotten into. So you would get to one like this, you'd say, well, when there's stuff on the inside, we got to do a u substitution because we got to take care of that with the chain rule, right? So that would be your hint. I'm not going to get in. We're not probably going to have to do this on the gateway test unless I gave you, some direction like that. So your hint here would be, okay, we have to do a u substitution because we got some stuff on the inside. Even though we are only going to get x dx and there's going to be an extra x squared here. But then you're going to be, oh, there's an extra x squared. Well, I've got an x squared right here as u, so I can put that in. Okay, So you might have, even without that, have thought of trying that, possibly. Okay, so let's do our substitution here. And so this part will just be e to the u, right? This part will be e to the u. We got remember x cubed would be x times x squared, so we've done one similar to that. And so this 2 is kind of in the way, so I am going to divide that over. And I got x dx, okay, so I can take out this x and the dx, and I can replace it with a 1/2 and a du. And so everything's taken care of here except this x squared, but we know x squared is u, so we just put that in there. Well, isn't that looks very much like the very first integration by parts one I did, right? That looks very much like the very first one we did in this class was x e to the x, okay? And that's what it is. It's an integration by parts. Now, the problem is I got u in there, so I'm going to really quickly change that to w's. See how I did that? Okay, I'm going to change those to w's because I want to use u and v. So I'm going to change all those to w's. Okay, pretend I did that as a dw and w and dw problems. Okay, so now this is an integration by parts. So now I got algebra and I got exponential. Well, in LIATE, algebra is going to come before exponential. So I'm going to let u equal w, and I'm going to let dv equal the e to the w dw. So du is just dw, and v would just be the antiderivative of e to the w, just be e to the w. Now I can't forget about this 1/2. Okay. Well, it goes with everything. I mean, so I'm going to distribute it probably. I could probably have left it, to be honest, I could have probably left it on the w here and then left it here. I could have done that. But probably not. Probably just leave it and then just do that. Okay, it's probably easier. So u times v, so w times e to the w, minus the integral of v, which is e to the w, du, which is dw. So that's easy, that's just e to the w. So the whole thing is just 1/2, I'm going to distribute it right now, 1/2 w e to the w minus the antiderivative, that's just e to the w, so that'd be 1/2 e to the w plus c, and then we bring our w back in, which was x squared. So it's 1/2 x squared.
Do you use the plus c for business integration?
There's always a plus c when you're doing the antiderivative. You know, unless this was a definite. The plus c always comes at the very end. After you're done doing your antiderivative, you tack on your plus c. But unless it was a definite integral, then you leave off the plus c. So there it is right there.
So we're not going to have any like this table?
Yeah, I wouldn't worry too much about that part of it. I mean, certainly worry about the two different aspects of the problem. You know, what a u substitution part would look like and what, especially this part, you know, because that's, no, I wouldn't. But I do want you to see this. I do want you to see some of these ideas here. Okay, for example, before we leave integration by parts, let's talk about number 20. And if you want to write it down, you can, but this is another one I'm telling you is not going to be on there. But what was number 20? I didn't assign it, but I did have a couple of people. Because I think number 20 is on the assignment sheet, but I said 15 through 19, but the assignment sheet says 15 through 20, so some people did. So it's what is it? The integral of?
Yeah.
Okay. 1 to 4. Okay. Cosine of 2x. Okay, here's what I'm going to do. I know. I'm going to leave those out because here's why I'm going to leave those out. Because what's going to happen with e to the 3x? Well, you have to kick out 1/3, or you'll have a 3x if you're doing the DU or whatever, right? Those are just gonna make these constants show up, which is fine. You have to be able to do that. But for right now, the point I'm trying to make, I don't want those to kind of get in the way. So to be honest, I don't really even care about the 1 to 4 right now, because all we do with those is at the very end, right? We plug those in. So I'm not even concerned about those right now. So let me just tell you about this special situation. So I already showed you one integration by parts where then you had to do a U substitution. We did a U substitution and then you got to do integration by parts. I also showed you an integration by parts you had to do twice. Remember that? Remember you had to do it twice? Or we said it 3 times, 4 times, 5 times possibly, you know, if they were higher powers, which would be a pain. Well, this is even another special situation that happens with an integration by parts. I got exponential and trig. So which one am I going to pick? I'm going to pick trig, right? So I'm going to let u equal cosine x. And I'm going to let the dv equal e to the x dx. Right? So the du is negative sine x dx. And the v would equal e to the x. So integration by parts would be uv, so that'd be e to the x cosine x, right? Minus the integral of v du, so that negative would turn to a plus, sine x dx, right? So Max is already kind of seeing what's happening, so all of a sudden you get this, right? And how do you got to do that? Do the same thing, but it kind of feels like what's going to happen is you're just going to go back to cosine, right? You'd just be flipping back and forth. But, and yes, that's true, but we're not going to do it forever because watch how we're going to do this. So let's do that again. So let's do u equals the sine x this time. Pick the trig. The dv will equal the what's left, which is e to the x dx. The du is cosine x dx. The v is e to the x. So now we do this integral. Now remember, we still got this hanging out over here. So we got this on the left, but it's still a part of it. So we got it. Did. Okay, so this is u times v. So e to the x sine x minus the integral of v du. So that'd be e to the x cosine x, right? dx. And then if we bring this down, we have e to the x cosine x plus all that, right? So that feels like we're in this endless loop, right? And we're just gonna keep going. So since we're back to where we started with, I'm gonna write this. So this line right here, isn't that equal to this right here? And isn't this what we're trying to find, right? We're trying to find this equals what, right? So wouldn't it be okay to put this down here, e to the x cosine x dx like this, equals all that? Would that be a true statement? Right? This is my original problem. I'm trying to find it, so I wrote it out. So this is equal to this line, and then I did integration by parts on that, and so that's that. So all of this right here is equal to my original problem, right? That's what we were trying to find. Okay, well, any ideas looking at that? How about if you add this integral over to this side, that's the same? And so then all of a sudden, don't you have 2 times the integral of e to the x cosine x dx equals e to the x cosine x plus e to the x sine x. And then what? And you're done. Right? So that's just another little trick. That always happens when you put a trig with an exponential, because you think about it, their antiderivative and their derivative are basically the same, and they bounce back and forth. And so that's just a little trick of how you would handle that situation, because after 2 times you're going to get back to what you started with. And you get that. Okay, so again, not one I'm going to have you do on there, but that's another thing that can happen in the integration of problems. All right, how about the LH packet? I want to do that one you asked about, Will. 23. Yes, ma'am. I think we might have. Okay, now these are mostly U substitution ones on here. The only really integration by parts are that 8.1 in the book, and then the website, a couple of those websites I've got have some, and we're gonna spend a little time looking at those today too. Okay, so you had square root of x minus 3. Well, that was on the bottom, though, right? Square root of x on top. So square root of x over square root of x minus 3 dx. Right? Okay. So, you can't split it apart, right? Feels like one of those where we pick a u substitution, then we can split it apart the other way because we can flip it around, right? In other words, we let u be the bottom. So that was kind of a typical thing to do. Let u be the bottom. Now here's where we run into some trouble. Here's where, and you wouldn't know this right away. So square root of x minus 3, of course, which is x to the 1/2 minus 3. So normally you do your du, right? So you get 1/2 x to the negative 1/2 dx, right? Which is 1 over 2 square root of x dx. Sometimes I rewrite them because it's nice to see, it as a square root, whatever. Now, when I go to substitute this stuff out, I can definitely see the bottom is u. Okay, so I got that. So that takes care of the bottom. What about the top here? Isn't square root of x the same as u plus 3? So remember we talked about solving for x? Do you know you actually have to go all the way to solve for x? You could just do that, right? And so couldn't the top, because this is not working for me right here, right? This is not helping me, really, right here. Usually I look for this to be in there, but it isn't. The square root of x on the bottom, that's not the same as that. Plus I've already subbed that out. So this is a problem, this du, but I'll deal with that in a second. So the square root of x is just u plus 3, right? Now here's a great example of when people don't put the dx in there or the du in there, where you would run into difficulty here. Because if you think you're done substituting, see, that's where you're wrong. You substituted this out, and you substituted that out, but what haven't we substituted out? We haven't substituted out the dx. And you have to. Okay? Now, a lot of times, it just kind of comes out automatically with our du, and it subs out real nicely. And when du is equal to dx, it's really nice, because then we just pull it straight out. But here, it's a problem. So, ideas.
If you have left the top as the square root of x, and put the u in on the bottom, and then put your 1/2 root x in, so you have root x on the bottom.
Say that again now.
So like you have root x over u in that integral, and then substitute in your du as 1/2, or pull the 1/2 out and put the 1 over square root of x in. Maybe they cancel out.
What do you mean put it in?
Like substitute your dx out.
What do you mean substitute it out? So when I take it out, I have to put in its place what dx equals. You know what I mean?
Yeah.
If I take out an x, I got to put in what x equals, right? So it's like right here, I took square root of x minus 3 out because it equaled u.
Did you put in 2 root x for du, 2 root x du for dx?
Okay, now, so that's where I thought you were going. Could I multiply this over and have 2 root x du? Now, I'm not a big believer in mixing x's and u's, but if you can get them to all cancel out and work out at the end, that's not all bad. Okay? So, but it is okay. I mean, so it is true that dx is equal. It is true that dx is equal to this. So what you're telling me is, okay, I got that as my u. That's true. I'm just leaving that there for right now, but I'm going to have to get it out there, right?
Put in the u plus 3.
So should I just go back to where I had that before?
Yeah.
Anyway? So put in my u plus 3, I agree. Because my square root of x is my u plus 3. And now to get the dx out, yeah, I don't mind doing this. I don't mind solving for dx here. That's not all bad. Solving for dx here, because that's the only thing left you got to get out of there. So you got to solve for it. So, but how do you put that in over here? The 2 I get.
Well, can't you put root x as
U plus 3 squared.
Exactly. So now, when I go to put in, so for my dx, I'm going to put 2 and then root x, but what's root x? So put another u plus 3 and then my du. Now, here's another way we could have looked at that. Right here, when I had this right here, there's another way I could have done it. Instead of solving for dx right here, I could have went ahead and solved for x right here, which would have been this, right? And now do the derivative of this. In other words, what's the derivative of x in these problems? Dx, right? 1, but dx, right? In other words, I'm going to do the derivative of x with respect to u. I'm going to do like dx du, and then move the du over. So the derivative of this side is like dx, and the derivative of this side would be 2, and then u plus 3, and then du. Well, isn't that what I ended up with? 2, u plus 3, and then du, right? I end up with the same thing, because right here, this is 2, u plus 3, and du, right? You see what I mean? I ended up the same place. So if I ever find myself in a situation where I've got this dx is the only thing left, and I got to get it out of there, I either solve this for my dx, or solve this for x and then do the derivative, and that gives you dx, right? It's 6 of one, half dozen of the other. Same idea. Okay? So, now what do we do with all this? You're going to FOIL, like, that's 1, right, on the bottom. So you got u plus 3 times u plus 3. So that's going to be u squared plus 6u plus 9 all over u. And now we're just going to divide those up. Now I'm going to distribute the 2 through there while I do this, because I don't want to just hang it out there. So u squared over u is u, so that'd be 2u. Now remember, I haven't done my antiderivative yet, so I still need my integral symbol there, because all I'm doing is simplifying. 6u over u is 6, plus times 2 is 12. And then 9 over u, and then times 2, so that'd be like 18 over u du. And now I do my antiderivative. So I get u squared plus 12u plus 18 ln u. Remember to put the brackets, plus c. And then I put my u as root x minus 3. So root x minus 3 squared, 12 times root x minus 3, plus 18 ln root x minus 3, plus c. There you go. That you definitely could have Wednesday. That's just one of those u substitution ones, but the only difference with it, because we've talked about the ones where we got to solve for x, where you got to do that to make that substitution. What we haven't really seen is then you kind of got that extra just dx floating there. But remember what we said. You can rearrange anything in this line here to make the substitution you need. You can move things around, and it's okay to mix x's and u's, but eventually you got to end up with just u's. All right, anybody have any others?
28, if we just memorize what the antiderivative of tangent is, does that work on that antiderivative test?
Absolutely. What was the problem with 28?
Just the tangent of 5x.
You have to do like 5 parts, and then you end up getting your integral is just like the
And had 10. Well, not on this one. You're talking about the LH factor.
Yeah.
That wasn't the original part.
Oh, it was tangent of 5x.
Yeah, it's just tangent.
Yeah, so you could just kick out a 1/5. Yeah, and the same thing with cotangent. I mean, if you want to take tangent, cotangent, ln x, was that one we did?
On Friday, we did the tangent and antiderivative of tangent.
And did we do the antiderivative of ln x on Friday? I don't think we did. I mean, if we're talking about our basic, we did arc tangent, I think we did arc tangent was one we did. We did And we had done a tangent antiderivative before, but that was just a u substitution. If we're just talking about our basic, and what was tangent? It was ln, negative ln cosine plus c,
Cotangent's just negative ln sine.
and cotangent is negative ln sine. Absolutely. If you just want to memorize that that's the antiderivative of tangent, then it shows up fine. Otherwise, we said make it sine over cosine, let u be the bottom, and just go, right? Either way. But if you memorize it, I'm fine with it. Well, here's another one. Here's a basic function that we deal with all the time that we have no antiderivative rule for, right? And the way you would get it is integration by parts. You would let u be ln x. Now, it doesn't look like an integration by parts because it's just got this one function in there. But that's okay. We did that with arctangent also. And then your dv would be what? Just dx, right? Whatever's left. So the du would be 1 over x, dx, and the v would be x, right? Antiderivative of 1 would just be x. So this would be u times v, so it would be x ln x, minus the integral of v, which is x, times du, which is 1 over x, dx. Well, x times 1 over x is 1. What's the antiderivative of 1? No. X. That's the antiderivative of ln x right there. That's the antiderivative of ln x. You had to do integration by parts to get it, right? So, add that to your list on page 330. I'm not probably not going to give you that one. Unless I would expect you to maybe do integration by parts, but if you memorize it, that's fine. You know, I mean, so that again, we could have made that list longer, but it's how often are you going to run into it? It's not that often, so you know, so probably don't worry about it. But it'd be nice to know that if I did have it and I don't have it memorized, just set it up as an integration by parts. Okay, all right. Let's look at the website. Let's just get your notes out here. And your whatever, just practice here, and let's do. I want to take you to the couple of websites that we have that I've got for you on the website here. If you go down on our website down here to web links, and there's 2 places here that say antiderivative. So let's just go through a couple of them, and these can be places you can be practicing the next few days. And then I've got some problems that we're going to just kind of step through. I'm going to let you work on, and some of it will be homework maybe. Okay. So the first one, it says derivative and antiderivative practice number 3. So you click on that, it takes you to this Jacksonville University. Remember we said Math 140, that's derivatives. Math 141, that's antiderivative. So if I just click in here, I'm not sure if they get harder as you go. I don't think they do really. Here's test number 5. Okay, so now their particular test looks like they have 8 questions and they have to get 7 out of the 8 right. Okay, so here let's don't work it through necessarily, but what would you do for this one right here? Let u be the inside ln x, because the du is 1 over x dx setting right there, right? So you're going to end up with u to the 3rd, which would be 1/4 u to the 4th, right? I mean, pretty straightforward. What about this one? That's the integration by parts. That's interesting because oh yeah, that's right. I think I said that was going to be that way. Number 4 is the one I said we would always skip on these. That's the integration by parts. Now that's one you actually have to do twice. That's the one we did the other day, actually. We had to do it twice. This one, split it up. X squared over x squared, x over x squared, right? Split it up. Okay? This one is one we skip every single time. Okay? Here is a u substitution. You got sine on the inside. Here is an integration by parts, x times sine. Now you got that 4x in there, so Emily, that's like the one you asked at the beginning. That 4 just means you'll kick out of 1/4, right? Anytime you have to do that, if you have to do the antiderivative of it. And then 7 is also one we skip. That's not one. Well, you know what? This is an interesting one. I'm not going to make you do this one, but this would be worth talking about. Anytime you have 1 plus x squared on the bottom, or square root of 1 minus x squared on the bottom, you should be thinking of what? Arctan and arcsum, right? If you got another number up here, it doesn't matter. If you got an x up here, that's a different story. But if you just have a 1 or just a number up here, you're probably thinking arctan. What if it says 16 plus x squared? Is there any way you can turn 16 plus x squared into this? Into 1 plus x squared? Well, the answer is yes. We can rewrite this as 16 times, we can pull out a 16. So if you pull out a 16, what do you got right here? 1. What do you got right here? You got 1/16 x squared, right? Because when you take, so now, what do you got there? So now this is just a 1/16 that you could just bring out in front, right? And you now have 1 plus, and now this would be the same as 1/4 x all squared, right? And what would you let your u be? Let u equal 1/4 x. Your du would be 1/4 dx, which we could just move that over. So 4 du would equal dx. And so now, because here's a dx here, so now this whole thing, the 1/16 hangs out there. This becomes 1 over 1 plus u squared, right? Because this 1/4 x was our u. And then our dx comes out, and it's 4, so there'd be a 4 du. And so see how I turned that into an arctangent, right? So typically you'll see like a 9 plus x squared or a 4 plus x squared or, a 16 plus x squared. And you pull that out, and it's usually a perfect square because that makes this work in here. So it's usually a 4 or a 9 or a 16 or a 25 or something like that. I don't anticipate having you do any of that, but just understand that's just that algebra those calc professors love to make you do. And so we can usually turn those into an arctan, but the ones I give you probably wouldn't. I'm more apt to give you one like this. Right? So what would you pick for your u there? No? 4x. 2x. Because 4x squared is the same as that, right? And so you'd want that to be, you want this to be 1 plus u squared, right? Something squared. So what it is, it's 2x quantity squared. So you would pick your u to be 2x there. And then that would, you could turn that into 1 plus u squared down the bottom. So I'm more apt to give you that than this, okay? But that's where that comes from. So that is a, that would be a arctangent one. And then this one would be a u, let u be the bottom, because then the du is going to be sitting right up there, the e to the x dx, okay? So this is a good one just because those are some pretty good u substitution ones that give you the kind of the split apart ones that I like. They give you some integration by parts ones, like this was an integration by parts, pretty basic one. This one was one you had to do twice, so probably a little harder than what we would do. But that's not a bad run of those kind of u substitution. And, so when we're talking about what we want to do, it's got a pretty good couple of those you can do, and even a little bit of the basic with the algebra. So I do like those, and you've got, 8 of them there you can do for practice with the solutions over there. So this is a good website, okay? And then the other one is down here. This one probably isn't as good, but right here it does say some integration by parts. It's got some basic ones here, just a few for you to do. It's got this one, it's not bad. It's some algebra with a trig, it's some algebra with an exponential, it's some algebra with a log. I wouldn't worry about the arcsine one. We did that with arctan already. I wouldn't worry about that. This is going to be one you have to do twice with the x squared, so I wouldn't worry about that. And then this is that repeating one, right? This is that repeating one we just did, like number 20. So the first 3 here aren't bad. if you're looking for some more integration by parts practice, because our LH packet doesn't have any integration by parts. We only have those ones in the book. So these two websites are probably where you get your most extra practice with some integration by parts. Okay, and then if you go back, and right here it talks about use substitution. You click. Click. There we go. And it gives you some. Now, I'm not guaranteeing that these are all great. Some of them might get into some stuff that we haven't done or some harder ones, but it's not bad. But it won't let you go to the next one until you get it right. So here at the bottom would be the u, I think, 1 minus x squared, because you get negative 2x dx is your du, and the x dx is right there. So I think this would end up being a pretty good one. And then you check which one your answer is. I don't know. Let's say it's A. Did we get it right? Hey, we got it right. And they do it, and they show you the work. They show you, kind of the work, which is not bad. And it says, get your next one. And then they do this. This would just be a split apart one. It's kind of nice, so they kind of keep it in the same kind of writing we would as we work it, which is kind of nice. So you just split that one apart, subtract your powers. Okay, so it gets into some kind of weird power. So that's not bad either. So those are some pretty good ones. Kind of a mixture. I thought they were all going to be U substitution, but it looks like maybe there's some that are just regular algebra too. So both of these have some pretty good ones to do. So right here where it said integration by parts, and then right down here where it says lots of practice using substitution. Those are the only two places I would go on here, quite honestly. Some of these aren't bad, but I didn't think they're as good as those places, but certainly welcome to try those. Okay, let's do this next. I just made up some problems here. And so let's try those three right there. This is a -6 right here. -6 is that pattern. Okay. Questions on those? So first one was kind of a basic, right? Like we talked about, do some algebra. Had to distribute through there, and when you distributed, I can't remember what the numbers were, but wasn't it 5x to the 5th then? And then what was it? When you distributed, plus 5x to the -3, like that. So you raise that up to a 6, divide by 6. You raise that up to a -2, divide by -2. This one you got to remember to kick out the 1/4, right? Antiderivative cosine with sine. There was a 7 hanging out there, but you got to kick out a 1/4, so you got that. Okay, on this one. Now, remember how we talked about this one. So I didn't write out all that, but we talked about how you let u equal square root of x, which is x to the 1/2. The du was 1/2 x to the -1/2 dx. Move that 1/2 over there. And so you got 1 over square root of x dx, which was just setting in that integral. So remember you had sine square, so that becomes sine of u. And then this part is all there, and that just becomes the du, sine of u du, right? Because this part was just the du. So you got 2, so antiderivative of sine is negative cosine, so you get -2 cosine. And then this is where we said you had that, so that was your antiderivative. So then we said you had a choice, right? You could leave it as u's, right? And we said it was from 1 to 4, right? Well, you could plug that into here. Those are x values, so the 1 and 4 are x values. So you can go back to x's and use your 1 and 4, so you put your square root of x back in for your u. Or you can put your 1 in here, square root of 1 is 1, so that just stays a 1. And then square root of 4 is 2, so this becomes a 2, and then you can do that. So either way, it's the same. And so you put your 2 in, you put your 1 in, of course, minus and negative turns to plus. Of course, who knows what cosine 2 or cosine 1 are, so you just leave them, right? Okay, like that. And then the third one was what? Integration by parts. Now, what? Yeah, that. And the key to integration by parts, and the key to this one, you had that 7 in there, so it was algebra and it was trig. So Liate would tell you that you're going to do algebra as the U and the trig for the DV. Now notice I have these backwards from the way we've been writing them here lately, because I did this a few years back. It was only last year I kind of started writing them the other way. But so usually I have the V up here, okay, like that, whatever. Doesn't matter.
I had everything the same, but I didn't have 7 over 81.
Well, because you have to kick out a 9 here again.
Yeah, I got 1 over 81.
You got what?
Well, I didn't have the 7.
Okay, the 7 on the top.
Yeah, I had 1 over 81.
Okay, so let's talk about this right here, because here's another thing that people sometimes mess up here. So you let U be the trig part, or the algebra part, which includes the 7, and then the dV be the rest of it. Now I should have had a dx at the end of that. So your du is just 7dx. Now, remember we talked about this last week. Well, in the other class we did, I think we did in here, a lot of times you want to divide that 7 over here, right, when we're doing U substitution, but not here, because we're doing uv minus the integral of v du. So when we put in du, we want to know what does du equal. Du equals 7dx. So this would be u times v, so 7x, so right here, Will, 7x, and right here when you go from dv to v, remember you're doing the antiderivative, you got to kick out a 1/9. So this would be 1/9 sine. So when you take u times v, that's 7/9 x sine 9x plus 9 minus the integral of v du. Well, you've got this 1/9, and then you've got this 7 here, Will, right here. So you got 1/9 times 7. You do not move that 7 over there, because what we want v times du, and du is equal to 7dx. So we got to take that 7 times that 1/9. So that's 7/9, and then I just pulled that out, and then sine of 9x plus 9. Now when we do this antiderivative, we got to kick out the 1/9 again. So that's where you get the 81. Of course, antiderivative sign is negative cosine, so that's why that turns to a plus. Okay? So you just gotta handle those.
I think I just forgot to add it over at the 7 times.
Yeah, I don't know, but you got to keep track of them, right? Because gateway test, right or wrong, right? So you can do a whole bunch of stuff right, forget that 7, then it's wrong. So that's why you got to practice. And I know it's easy to think about what Max said. I don't want to do any of these. Well, that's fine. Just depends how many times you want to do the gateway test. But maybe you're good. Maybe you're good. But the streets are littered with calc students who thought they were good enough going into the gateway test and took it 4 times. And should have had a 30 out of 30 in their grade. Instead, they had a 24 out of 30. All right, here's 3 more. Make sure you copy them all down real quick here. Make sure you got all 3 of them copied down, because I'm going to show the answer at number 4 here. So it's going to go away. Everybody's got them copied? 3 of them? Okay. There's number 4.
Are these just like really similar to what we're gonna see in Gateway?
Oh, reasonably, I would say. I mean, right, it's been the 3 things we talked about, kind of basic, use substitution, integration by parts. I mean, those are the, you know. I mean, obviously, it's hard to cover all the different possible ones we've done in just a few, but you partner this with the website review and then some more than in the LH packet, whatever. Okay, you want to see 5? What'd you have for 5? Anybody have their final answer for 5? -1?
Yeah.
What'd you have?
I had like 4 and 6 months.
Okay, anybody else?
Maybe I'd copy it down, actually.
Well, through the first 4, is there anybody who's still in the running to get 8 out of 10? The answer number 5 is 1/30. Wouldn't be LN. You let U be the bottom.
Wait.
I don't even have
What?
That's what I have. I don't understand.
Because the bottom was 6 minus, what was it? 6 minus LNX
That's what I have.
squared. What was the top? Or was there a top?
Top is 1. Alright.
And was there another X down here?
Yeah.
There was another X down here on the bottom. There's an X down here on the bottom. Is that right? Is that what it was?
Yeah.
So you let U be the inside. The du is -1 over x dx, which is sitting right there, right? Except for the negative. So you got the negative there. And then you got the, this would be u, 1 over u squared, which would be u to the -2. So you raise that up 1, it'd be -1, divide by -1, cancels that. So it'd be 1 over u. So there's no ln because we've done our antiderivative already once we get to here. Now there's ln in here. So what did I do? I had 1 and e. 1 and e were our original. So if you want to go back to your x's, 1 over u, that's fine. Or you can plug in your 1 and your e. So if I put an e here, ln e is 1, 6 minus 1 is 5. So that's where the 5 comes from. Take the 1, plug it in here, ln 1 is 0, 6 minus 0 is 6. So that's where the 6 comes from. So I can just go 1/5 minus 1/6, which would be 6/30 minus 5/30, which is 1/30. Or I can plug it in here, same thing.
I forgot it was squared or the negative second. Yeah, so I just had u to the negative first.
So you had 1 over u.
No, right there. I thought that
Right
was,
here.
Yeah.
That's what I'm saying. So you have 1 over u here, so you had negative ln or something. Yeah.
Yeah.
Little things. Okay, what about the last one? Have you had time to finish that one?
Yeah.
Yes and no? So you had an algebra, and a log, so you're always going to pick log as your u, liate, L comes first. So 1 over x dx, your v, remember we're doing antiderivative, again this is backwards from the way we've been writing it. But now, I kind of shortcutted some of the work here, so you got u times v, so ln x times this, I put that in parentheses, that's important, minus v du. Well, I could tell I'm going to have 1 over x times this. Well, you're going to distribute that when you take v times du. So 1 over x, that's going to cancel that, make it x to the 5th. That's going to cancel that x, make it 8. Okay? So just so you understand. And notice how I distributed my minus sign through here. So you have to make sure and do that. Raise that up to a 6. Divide by 6 is 1/18. Antiderivative of 8 is 8x, but minus. So you're going to distribute or else have that in parentheses one way or the other. The plus c can always be a plus c. And then this is ln x times that quantity. That just stays the same. So yeah, I think these are pretty straightforward. So that gives you a little sense of how ready you are. Now it's not till Wednesday, so that's a good thing. You got a lot of chance to practice. And I didn't look at homework today. I'm going to do that tomorrow. I guess I better do that. So you got some problems to work on. All right, let's look at a few more. So where are we at here? Let's go copy those down. Just copy them all down. Copy these 3 down first, because we still got a little bit of time, but I don't know how much time we'll have here. Make this part of your homework tomorrow. We'll finish these up. Here's 2 more to copy down, number 10, number 11. Is that what you got for number 7? Huh? How'd I get it? So add those powers, so that'd be x to the 7/2, 3.5, minus, and then 1/2 plus 1, right? Add the powers. So it'd be 3/2. So then here you got to kick out a 1/4 because of that, right? So that's 5/4 e to the 4x. And then this one you'd raise up 1, it would be 9/2, and then divide by 9/2, so that'd be 2/9.
So you kind of subtract those and then do the raise it up and divide.
Say that again. Yeah.
Take 7/2 x to the
Power
7/2.
rule, raise it up 1.
Oh, see, I took x to the 7/2 minus x to the 3/2.
No, you can't do that because they're not like terms. I mean, that's like if you had 2x squared plus 3x plus 1, you can't add 2x squared plus 3x. They have different powers, right? So you can't put those together. So then 2/5 x to the 5/2. Yeah, you can only add like powers or like terms. So, yeah. Okay, and then number 8, split that apart, right? Split that apart and then put in your number 8. 5 fourths e to the fourth minus 1/4? No, yeah. So I'm glad you said that. Because I get people doing that, especially when it's just like E's and stuff, it almost feels like X's. Yes, on the gateway test, if you forget plus C's, I'm probably going to remind you. Hey, don't forget to do a plus C, don't forget plus C. On a definite integral, you should never have a plus C, right? Definite integral, the answer is a number. There is no plus C at the end of it.
Will we miss it, or we just?
Well, I'm going to remind you. So, because number one, you should never do that. Number two, I'm going to be reminding you. So if you do it, yeah, I might. Because if you went at the end and just put plus C's on everything, it's like. Okay, so for tomorrow, you got multiple things you can do. You need to finish these 11, these problems here. The LH. So if you go to you go to our assignment sheet. Go to our assignment sheet, there's all kinds of, right down before antiderivative, there's a few more in 8.1 you can do. There's page 356, page 310, page 341 in the LH, in that new LH packet. So there's a bunch of them that you can pick, and these are just random ones that I thought were good ones, so I threw those on there. But you can do more than that, for sure. Ones that are around those would be good. And the 2 websites, plenty of things you should practice. Right? So I'm going to come around and check, and then I'm going to decide if I think you did it. How's that for leaving it wide open?
Your definition of enough is a lot
Right.
broader than ours.
It's a lot different, and I'm going to give you the grade based on my definition of enough, which you don't really even know what that is. So you better know. So if you're not sure, you better do more.
Everybody else in the class, so whoever does
So
the
you-
most gets 100. whoever
No.
does the second most gets a 90.
No, I know how you guys are. You'll plan it out and say, okay, everybody do 2. Everybody do 2 problems. We'll all get 100.
We only get 12 problems. Only get like 30. Even if everybody did 2, we would get